Ethanol can be used as a liquid fuel. A student investigates how much heat energy is released when a known mass of ethanol is burned. The apparatus is set up as shown in figure 3. A known volume of water is placed in a metal can. The temperature of water is measured. The ethanol is ignited and placed under the beaker so that the flame is touching the beaker. The water is heated by the flame is extinguished, the final temperature of the water is measured. So we're basically transferring the chemical store of energy, or the energy in the chemical store, to the thermal store and using the temperature to measure that energy transfer as an indication of how much energy ethanol contains. So the theoretical temperature rise for burning a given mass of ethanol is 82.4 degrees Celsius. So that's what we should expect. In the experiment, the actual temperature rise for burning this mass of ethanol was only 34.8, so that's a lot lower. One reason why the temperature rise is less than expected is that the ethanol does not burn completely, so not all of it is actually burnt. Give a reason why, even if the ethanol burns completely, the actual temperature rise is much less than the theoretical value. Well, if we look at this system, it's a very open system. The heat is going to be escaping to the environment. If this is hot and it's not going to be as hot in the environment, the heat will transfer very quickly to the environment. So a lot of that heat will escape and not be picked up by the thermometer. So some heat escapes. Explain how the method described above could be improved to give a temperature rise closer to the theoretical value. Explain. So say what you do and explain why that would benefit. So the obvious thing is if heat escapes, you need insulation. So use of a lid or insulating material. Why? So more heat energy goes to the water and less escapes to the environment. The amount of heat energy used to raise the temperature of the water by 34.8 degrees can be calculated using heat energy equals 210 times temperature rise. Calculate the amount of heat energy used. So that's pretty easy. So we're just doing 210 times 34.8. They give you the temperature rise in the question here, so you're just linking that temperature rise to 210. Probably one of the easiest calculations I've seen in a science paper. So there you go. Energy units would be joules.